The Turtlebot is a great little platform to learn ROS and to play around with the different algorithms and so on that you can use in ROS. But sometimes it's not convenient to actually have a robot. Sometimes you don't even have a robot. So you can definitely still work with that, but then you have to use simulation. So let's see how we can simulate a Turtlebot. In our virtual machine here, we already have installed everything that we need in order to simulate the Turtlebot. So the way to launch a Turtlebot simulation is by writing ROS launch Turtlebot Gazebo, and in Gazebo you can double tap and see that there's a couple of different demos that you can do. I'll take the Turtlebot world. It's the least demanding because the other two are going to do some advanced, more advanced navigation. So let's take the Turtlebot world launch file here and run it. And what will happen now is that we'll open up Gazebo. Gazebo is a simulation environment, and the Turtlebot world already contains some models and so on for this. Yes, this is a great example of how Gazebo is unstable, especially when running it on virtual machines. So I'll just click Control C in order to stop everything now. And we'll wait until it has stopped, and then we can restart it. And usually I'll just try and restart it when this happens. It's unfortunate, and it works better if you have a native install of Ubuntu on your computer. I'm using a virtual box, so that's why it's problematic once in a while. So some things are happening here. And what we see here is that we have a Turtlebot in an environment with a box and a container. Over here we have a bookshelf and like a concrete block or something like that. The Turtlebot is looking in that direction along the red line. So the first thing that we can do when we have this running is to open a new terminal. And in that terminal, we can run the tail operation, a tail operation node. And we do that by ROS launch turtlebot tile op. And as you can see, there's a couple of possibilities. We have the keyboard, we have a PlayStation 3 controller, Xbox 360, and a Logitech, also a gaming controller. We'll stick with the keyboard for now. So you need to keep this terminal, alive in order to input something. But you use these keys on your keyboard. So I for forward and U and O to drive forward while turning. So I'll press O and we'll see the robot starts moving. All right, and I can go forward like this. So you can play around with this and get to know your robot. You can increase the speeds by using these keys. Okay, so this is all interesting, and this is the way to get to know a Turtlebot without actually having a Turtlebot. But we've also been developing some software for the turtlesim, and actually the interesting thing is that the turtlesim and the Turtlebot uses the same input. So we'll open another terminal, and we'll see here that if we say ROS node list, you'll see that there's a couple of nodes here, and one of them is the Turtlebot tilop keyboard. So we'll say ROS node info Turtlebot tilop keyboard, and we'll see that it publishes on this command velocity mux input tilop, which is different from what we saw in the turtlesim, which was turtle1/cmdvel. But the reason for this is that this Turtlebot might have several inputs for the commanded velocity. So we have what we call a multiplexer, and we have several inputs. One of them is the tail operation. So this tail operation goes in through this command velocity mux. So let's have a look at how that looks, and we can use that through the RQT graph. There we are. So the RQT graph shows that the Turtlebot tailor keyboard, I'll just zoom in a bit here, goes into this CMDville mux input tilop. There's nothing more here because that's the only one that's actually providing an input now. But if we had some navigation, automatic navigation, it would also go in there. So we could have a look at the leave topics and that syncs. There you are. And as you can see, the command velocity mux have several inputs. One of them is the navi for navigation, and we also have the one that's called safety controller. So these are prioritized so that the navigation will try and bring the robot somewhere, but if the safety controller deems that this is not safe, it'll take over. So anything that it puts in will take priority over the navigation, whereas the tail operation takes priority over both of them because this is a human and he knows best whenever he's sending something. So that's the reason for this. And this goes to the mobile base. And you can sit here that there's like a lot of things to look at, and you can try and investigate how the system looks. They are, you can see this portion here is related to the camera. These portions are related to the simulation, which is not on a real robot. And this is for the input of the motion. So let's close this down and then try and go to our robot programming workspace, where we have in the source folder, we have these turtlesim games we've developed, but also in the one that we call my first package, cd source my first package. Recall that we had this one, the round node, and the round node made the turtlesim go around and round and round. Actually, we developed this further on so it would go out in a spiraling motion. So let's try and run this. Ross run my first package. That won't work until I source rprodevel setup bash. Then Ross run my first package round. Okay, so if I go and have a look here, nothing happens because the two nodes are not talking together. If I open up, well, I can close this one and we can have a look. Ross node info, it's called round, I know. And you can see it spits out on publications on Turtle1 CMDevelop. So we want this specific topic to go to the one that we had over here that was called CMDevel mux input tilop, right? So this is actually quite easy in ROS, and this is one of the powers of ROS, that we can actually, that was this one. We can stop this one, and then we can run it again, but this time we'll say the thing you published on turtle1/cmd_vel, we want that to be remapped into the cmd_vel mux input teleop. Right, there we go. And if we look in here, our robot starts moving, and then, you know, these inputs weren't really designed for the Turtlebot, and it just starts spinning faster and faster and faster, and, you know, But the thing is that it's the same data that we're sending. Maybe we should send some other values, and it goes completely crazy, and it's fun to look at. But now, because you know how to make packages for the turtlesim node, you can see now you can actually also use it, almost the same node, in order to make your Turtlebot move. So the next step will of course be to connect to a real Turtlebot with your computer that you have here.